Hello everyone, welcome to the Tech Buggy classes, a new way of learning. So today we will discuss about one of the major topics in digital electronics world. So we are all studying about digital electronics like combinational circuits, sequential circuits, shift registers, FSMs, and all. We are all studying about these things, but we know that how to design the circuits, truth tables, expressions, and all. We are all know about only about the paperwork only. So we will use RTL programming for the digital circuit designs. Okay, so let's get into the topic. So first of all is what is RTL? RTL is a programming language which describes the behavior and functionality of a digital circuits at the register transfer level. So mainly it focuses on the flow of data between registers and the operations performed on the data. So for example, if we consider AND gate, OR gate, NOR gate. So whatever the gate, and also for example flip-flops, for example shift registers, FSMs and all. So we know how AND gate will perform the, I mean how AND gate will work and what flip-flops will do, what shift registers will do, what FSMs will do. But we don't know how to visualize them. So for the visualization purpose, we are going to use one programming language. So that is Verilog HDL. So we are mainly focusing on this Verilog HDL. So Verilog HDL is a programming language which describes the functionality and behavior of the digital circuits. For RTL, here for RTL we are using Verilog HDL, or we can use VHDL, or we can use system Verilog languages. So in our lectures, we are going to use Verilog HDL programming. Before going to coding part, we need to know in how many ways we can write the Verilog coding. So by using a Verilog HDL, we can model and simulate digital circuits. We can synthesize and optimize the designs. We can verify and validate designs. We can generate the gate level netlists also. So we have different levels of modeling the digital circuits. So the first thing is gate level modeling. It describes the circuit in terms of individual logic gates and their interconnections within the circuits. So for designing gate level modeling, we need gate level diagrams. Gate level diagrams. So if you know the gate level diagrams, then only we can choose gate level modeling. For example, AND gate. I know the structure. I mean, I know the diagram of the AND gate. For example, OR gate. For example, NOT gate. So if you know the gate level diagram, then only you can opt gate level modeling. And the second thing is data flow modeling. It describes the behavior of a circuit based on the flow of data within the circuit. So this is when you know the expression of particular digital circuit, then only you can choose the data flow modeling. And the third one is, this is the very important one. When you, I mean, behavioral modeling, it describes the behavior of a circuit in terms of algorithms, procedures, and control flow rather than the specific gates or data paths. So we can opt this type of modeling when you know the complete functionality of the digital circuit. So complete functionality. So for example, for all these three cases, we can take one example, AND gate. So for example, this is my AND gate diagram. I know the gate level diagram of this AND gate. So we can use gate level modeling. I know the expression, for example, A and B. So A is our input, B is our input, Y is the output. So this is the expression for the AND gate. So we can use data flow modeling and also for the behavioral modeling. If you know the functionality, whenever A is 0, B is 0, the output is 0. So whenever A is 0, B is 1, the output is 0. Whenever the A is 1, B is 0, the output is 0. Whenever the A is 1, B is 1, the output is 1. So this is the functionality. So functionality, what is meant by functionality? So whenever we give some inputs for a particular digital circuit, based on that inputs, how our circuit is behaving. That is called the functionality of the digital circuits. So these are the three different level of modeling the digital circuits. And next thing is, so we are talking about Verilog HDL. So for that Verilog HDL programming, we have some structure way of coding, way of coding styles. So I don't think that it is the toughest programming language. So if you have a basic C language knowledge, we can easily write the Verilog HDL. So if you don't know about the digital circuits like combination circuits, sequential circuits, shift registers, FSMs, in combination circuits we have AND gate, I mean basic gates, mux, demux, encoders, decoders, and adders, subtractors, and also in sequential when it comes to sequential latches, flip flops, and some counters, Morton counters, shift registers. I mean serial in, parallel in, serial out, and when it comes to FSM we need to know alien Moore missions, overlapping condition, and non-overlapping conditions. We need to know all these topics. Whenever you know all these topics, you can write the Verilog code. Without knowing those things, you can't write Verilog programming for the digital circuits. So, for this entire course, for this entire RTL programming, we will follow one structure. So our job will be easy. So the first one is module declaration. So what module declaration will tells us means it defines the name and the ports of the module. So for every module, we need to define one name, and also we need to define the ports. And the second thing is port definition. So port definition tells us inputs and outputs declaration happens in this module. So in this module, we can define the inputs and outputs and internal signals. So internal signals are the optional. So whenever we require, we can use this thing. So internal signals are declared within the module and are used for intermediate calculation or storing values. So we will see what internal signals are in the upcoming videos, upcoming programming. So we will use internal signals in designing sequential circuits. I mean, we will use more internal signals in designing sequential circuits. And when it comes to the fourth thing, data flow assignments, it defines how the, I mean, data flow means it defines how the output of the module and computed based on the inputs and internal signals. This can be done using continuous assessment. So in this data flow assignment, we can use assign. So what is mean by assign? Assign statement is used to specify the continuous assessment of a value to a net or y type. So what assign means? We can, I mean, continuous assessment of a value. Continuous assessment of a value. We are not going to use this assign in procedural blocks. Procedural blocks are always blocks initial. So we will see what is procedural blocks, what is assign, everything in upcoming videos. For now, these data flow assignments will. And the next thing is sequential logic. So the sequential logic, uh, if the module contains sequential logic such as flip-flops, registers, it is typically with an always block. I mean, whenever we are going to design some systems like flip-flops, Morton counters, what shift registers, FSMs, and all, those are all comes under sequential logics. In that sequential logic, we are using always block. So we are using always block is nothing but uh, always block. So always block syntax, always at the rate star, or always at the rate passage clock or neck gauge clock. So this is used for the combination circuits and this is used for the sequential circuit. We will discuss about all these things in upcoming videos. So the basic definition of always block is always block defines a set of procedural statements that are executed whenever there is a change. Whenever there is a change in the sensitivity list. In the sensitivity list. This is the sensitivity list. So always block defines a set of procedural statements that are executed whenever there is a change in the signal specified in the sensitivity list. So this is the basic always block definition. And this is the end module. Verilog code ends with the end module. So we will end the entire code by using this end module. So we will look into one example, that is AND gate. So if you don't know about AND gate, uh, I ping one link in the comment section. Go and watch that AND gate code. I mean AND gate functionality. So before, I mean, as previous I said that if you want to write Verilog programming, definitely you need to know the digital circuit knowledge. Definitely you need to have digital circuit knowledge. So here we are going to write AND gate Verilog HDL code. Okay. So here, I mean, this lecture is mainly focusing on the only on the Verilog HTL programming. So I will tell you in a simplified way, I mean, with a clear explanation. So please be concentrated. The first code is gate level. As I said, we have three different level of modeling. So the first level is gate level. So the first one is module declaration. Module declaration. It will recommend. So this is VS Code. In VS Code, there is an extension called Terras HDL. If you install this Terras HDL, I mean, we can write Verilog programming. It will highlights the terms and everything like this thing. I mean, I entered module and end module. It will give in a yellow symbol, and our module name is AND gate. So okay, AND gate. So in, I mean, after module declaration, what we need to do? The second step is port definition. So in port definitions, we need to assign inputs and outputs. Input A signal, input A. So, I mean, before this thing, I simply wrote input A. So for every variable, we will have some bit width. So we will talk about bit width in upcoming videos. For this gates, we don't require, I mean, that bit widths and all. In upcoming videos, for example, if we need to design a mod counter, we need to define everything. We need four bits to design mod and counter. So in that videos, we will talk about the bit widths. I mean, how we can assign the bit widths to a variable and all. So for this thing, we don't require. And we need to tell what are the inputs and outputs. Input B. So these two are the inputs for the AND gate. So here we are designing AND gate, which is having two input AND gate, two inputs AND gate. So we know the basic gate level, I mean gate structure of the AND gate. We have two inputs, one output. So the two inputs are, one is input A and another one is input B. And we need to define the output Y signal, output Y. So as I said, this is the gate level modeling structure. So in Verilog, we have some built-in primitives. So for gate level, whenever we are designing for the gate level modeling, we have some built-in primitives. For example, if we are designing AND gate, we have one built-in primitive called AND. Whenever we are going to design OR gate, so we have OR gate primitive, OR gate built-in primitive. So we'll use that primitive in this time. So output of the and get. So and is a Verilog built-in primitive. So we take, so the first term is output A comma B. This Verilog primitive and will do the function of that AND gate, will store the output in Y. So Y is the output and A and A and B are inputs. Okay. So and next thing is data flow modeling. So data flow modeling. So as we said that first thing is module declaration, module name and module. So first thing is input A signal, input A, and the second thing is second B signal, input B, and the third signal is output signal, output Y signal, is output Y. So as I said, the definition of the assign statement. So it is only used for the continuous assessments of a value to a net or void type. So here we will use the assign statement. Output of the AND gate. We are assigning the output to Y based on the inputs A and B. So this is the data flow modeling. So here we mainly concentrate on the expression. So this is AND gate primitive type. And here we need to know the gate level diagram. The third one is main thing, behavioral modeling. So as we know that the first thing is module declaration, and the second thing is, sorry, and the second thing is uh, code definition. So here we need to declare inputs, input A signal, input A, input B signal, input B. So here we are using always block. So for this always block, as I said, whenever there is a change, right? So whenever there is a change in the sensitivity list, the always block will be execute. So output y signal. So here we are going to use output range. So this is a combination circuit. Output of the indicate. So always at the rate star. So what always at the rate star will do means, so whenever there is a change, so for example we can use like we can also like always at the rate A or B. So we can use like this also, we can use star. So for combination circuits we can use the stars. So it will depend whenever the overall, I mean in this overall always block, whenever there is a change in a variable, so it will execute y equal to A and B. So these are the three different level of modeling and gate code If you have any doubts, you can post in comment section. So thanks for watching this video. Please do like, share and subscribe. So if you don't know about the AND gate functionality, please go through that video which I posted in the comment section about AND gate. So in that AND gate, we discussed about what is AND gate and the real-time examples, and also we discussed about CMOS circuits and all. So please go and watch the video, and thanks for watching, and we will meet in next video. Thank you.